Welcome back. Today we're going to focus on properties of logarithms. So now we can move past from the graphing. Okay, I promise today's going to be less painful, but we're going to focus on the simple properties that logarithms have. There's going to be three properties that we focus on over the next 2 days. Okay, condensing, expanding, and what we call change of base. Now, most of these things you've seen before, okay? So before we dive in, I just want to show you the basics of exponents because exponents and logs are connected, as are their properties. So multiplying and addition are connected for exponents, therefore they're connected in logarithms. So here, x to the third times x to the fourth, when you're multiplying, that is connected to addition. You know from exponents that would be x to the seventh, and in a few moments you're going to see how that is connected to logarithms as well. You know that division and subtraction are connected. If you're dividing exponents, you subtract. Well, you're going to see that same connection when we're dealing with logarithms. And powers connecting to multiplying, you're going to see that same, you're going to see that same thing again. Okay, so each of those rules that you became familiar with from exponents, they're going to be connected to what we're doing with logarithms. And here, if you follow the color scheme that I have here, you'll even be able to see that connection. Here, the product, you can see right here, when you're multiplying, you can split them up into addition. Quotient, when you're dividing, you can split them up via subtraction. Power of a power, you can split up by multiplication. So let me show you how this works in the world of logarithms. Okay, so we're focusing on condensing today. If I have multiple logarithms that I'm seeing, we're working on condensing them down to a single logarithm. Okay, this means any coefficient should be written as a power, and any adding or subtracting should be written as a single logarithm. Okay, so let me show you how that looks. So here, addition. Addition is connected to multiplication. So what this means is I have log base 2, but now I'm going to multiply 5 times 3x to give me 15x. Okay? To write it into a single logarithm, that addition equates to multiplication. All right, what about this one? Well, subtraction. Subtraction equates to division. So this time I'm going to have log base 3 of 10y squared divided by 5y. And this time I'll just put in parentheses to make it a little bit easier to read. So subtraction equates to division, okay? And with that division, this actually simplifies, okay? So log base 3, 10 divided by 5 is 2, y squared divided by y just leaves me with y. And that would be what it looks like as a condensed one. This number out front, that equates to the power property. Okay, remember, powers equate to multiplication. So that multiplication that's out front is going to become the power of whatever is in the log, okay? You bring it up top. Well, here if I want to write that a little bit nicer looking, I can call that 49x squared. The power will apply to everything that's in there, okay? But anything that's multiplying out front can be written as a power, or any multiplier that's out front can be written as a power. All right, well, so that's what the three basic properties look like in isolation. Let's talk about what they look like when we start combining them, okay? When more than one thing is happening. Now, if you notice in my instructions, the first thing I said to do was take care of those multipliers / exponents. Okay, so what that means is the first thing I should look out for in this next example is that 3. Okay, so that's the first thing I'm going to do. So log base 5 of 9 minus log base 5. That multiplier out front is an exponent. So 2 to the third gives me 8. So that's the first thing I take care of, is if there's any multiplier on either one. Now I can see that subtraction. That subtraction relates to division. So to write this completely condensed, log base 5 of 9/8. Okay, so these really only have those 2 steps. Okay, now let's move on to the next one. So here I see 2 multipliers, so I'm going to write this as log base 2 of x to the 5th plus log base 2 of, oh, I'm sorry, that's to the 6th. This one is y to the 5th. So I bring up both of those multipliers as powers. And next, now I see that addition. Addition relates to multiplication. So that gives me x to the 6th times y to the 5th. And there is my completely condensed logarithm. And finally, for this one, there's 2 ways you could go about this one. I think the easiest way is, in fact, deal with the parenthesis first, okay? Usually that's an easy thing in the grand scheme of things. So I'm adding in that parenthesis. So adding equates to multiplication. So log base 7 of a, b, c. Just multiply all of those together. Now I have this multiplier out front. So now let's bring that up as the power. So log base 7, a, b, c to the 1/4 power. Or another way you could write it, okay, if you think it's a little bit cleaner, is remember the 1/4 power is the same as the 4th root. So either one of those would be perfectly acceptable answers. You can either write it as a power or as a root when you're dealing with fractional ones. Okay, so that's the basis of all of these powers here, or all of these properties here. Okay, so let's take a look at how we can use these properties in order to help us evaluate some of these things. Okay, so again, looking at the properties, I see subtraction. Okay, so I'm going to divide that. So log base 4, 32 divided by 2 is 16. Now this looks awfully like what I had back in the first section of 7.3. I can actually evaluate that. Okay, so I need to picture to myself 4 to what power is going to give me that 16. Okay, and I think this one you guys can see is going to be 2. 4 squared gives me 16. But sometimes these properties will actually be to our benefit. It can help us find and evaluate some of these terms. So what about this next one? Well, I see a power first. So log 7(1) minus log 7(49). Subtraction equates to division. So log base 7 of 1/49. And now I want to be able to evaluate that. Okay? So to make sure I have enough space, well, I can write it like this. So 7 to what power gives me 1 over 49, okay? Remember, that's what a logarithm is answering. The base to what power gives you that number. Okay, so now I'm going to erase a little bit of this because I need more space to write this out. Well, what I'm seeing is 49 is 7 squared. Okay, that's the first observation that I make. 49 is 7 squared. I need to rewrite that number in the same base. Okay, and now I need to bring it back up. Well, to bring it back up takes a negative exponent. So my logarithm is going to be -2. Okay, 7 to the -2 power gives you 1 over 49. And you can even check that on the calculator to make sure you've done that right. All right. Let's move on to this one. So I see subtraction. Subtraction equates to division. So 2/16. Well, 2/16 reduces to 1/8. Okay. And again, here we're practicing the skill of, can I rewrite this? Okay, can I evaluate this? So I need to think about 1/2 to what power is going to give me that 1/8. Now, both are fractions, so I actually don't have to worry about the negative exponent piece here. Okay, what I do have to worry about is rewriting that 8 as a power of 2. Well, 2 to the third gives me 8. So if I take that to the third power, that is what's going to give me the 8 down there. And so that's going to leave me with 3. 1/2 to the third power gives me 1/8. And last one. Here I see addition. So addition equates to multiplication. So 2 times 3 gives me 6. So now I need to think, 36 to what power gives me that 6? Well, if I need to rewrite this in the same base, I need to rewrite 6 as a 36. The thing to remember here is 6 is 36 to the 1/2. Okay, remember that square root. The square root of 36 is 6. While in terms of exponents, a square root means 1/2. So really what that means is that logarithm would condense to 1/2. 36 to the 1/2 power is going to give me 6. Okay, so those are still those essential skills you need back from the first section. Okay, and I'm going to keep bringing it back because I know it's something that takes time to get really good at. So if you notice, almost every practice, almost every note is somehow going to incorporate this in because I need you to get really good at it, manipulating these logs. So thank you so much for watching this for me. So make sure you write that summary for me. Take a moment to reflect on the things we've talked about, and then come back ready to work on your practice work.